All right, next we're going to begin our algebra lesson. We're going to work on add, subtract, multiply, and divide rational numbers to solve real-world problems, the tutorial. So the way we get there is by clicking on all activities. You've got your list. It'll probably be the next one in the list. Click on it, play tutorial.
Add, subtract, multiply, and divide rational numbers to solve real-world problems. In this lesson, you will use the four operations to solve real-world and mathematical problems that contain rational numbers. Just as we do with integers, we can perform all four operations, addition, subtraction, multiplication, and division, on a set of rational numbers. The key to knowing which operation to use is to understand the problem at hand. There are many techniques you can use to solve word problems. One is recognizing certain keywords, such as deposit, rise, drop, and combine. These keywords can help you figure out which operation to use. When banking, for instance, all four math operations are useful. For example, if you deposit money in your bank account, you can find your account balance by adding the deposit to your previous balance. If you withdraw money from your account, you can calculate your account balance using subtraction. If you deposit a regular sum of money each month into a savings account, you can calculate the total amount you've saved over a period of time using multiplication or repeated addition. If you're repaying a fixed loan over a period of time and you want to know your monthly payments, you'd likely use division. In this lesson, you'll learn how to solve real-world problems using math operations and problem-solving strategies. Problem-solving strategies. There are many strategies you can use to solve problems. Some of these strategies include looking for a pattern, making a list, guessing and checking, making a table, working backward, using logic, drawing a picture, and trying to solve a simpler problem. Let's try one of these strategies. The weather report for Fox Point says the temperature will change from negative 12 degrees Fahrenheit at 5 a.m. to 7 degrees Fahrenheit at 3 p.m. What number represents the net change in temperature from 5 a.m. to 3 p.m.? We'll use the drawing a picture strategy to help solve this problem. Draw a number line that shows integers from about negative 15 to 15. Mark a point at negative 12 to represent the temperature at 5 a.m. This point is 12 spaces below 0. Now, from negative 12, move in the positive direction until you reach 7, and mark another point. This point represents the temperature at 3 p.m. Finally, count the number of spaces between negative 12 and 7. There are 19. The net temperature change from negative 12 degrees Fahrenheit to 7 degrees Fahrenheit is positive 19 degrees Fahrenheit. Because this change involved moving in the positive direction on the number line, the change in temperature is a positive value. Now let's consider another problem. Holly is sightseeing in New York City. She left her hotel in the morning with a certain amount of money. She bought a $27 ticket to visit the observation deck at the Empire State Building. Then she took a cab to Madame Tussauds. The cab fare was $9. At the museum, she paid an entry fee of $39, and later she spent $10 on lunch. If Holly had $200 with her after lunch, how much money did she have when she left her hotel? We'll use the strategy of working backward to find Holly's initial amount of money. When we work backward, We use opposite operations to solve a problem. We know how much money Holly had after lunch, $200. To this amount, we add the money she spent to find the initial amount. The calculations are shown in the table. Holly had $285 when she left her hotel.
So they continue to add up to find out how much she started with, even though the words that are used are subtract, subtract, subtract. She spent, she spent, she spent.
Solving real-world problems. Here's a problem that includes both fractions and decimal numbers. A submarine is exploring the Pacific Ocean. At 502.5 feet below sea level, the water temperature is 63 1/4 degrees Fahrenheit. The submarine dives down 115 feet deeper, and the water temperature drops by 2 1/5 degrees Fahrenheit. What were the elevation and the water temperature after the submarine dove? In the next activity, you'll solve this problem one step at a time.
Okay. So again, here's the directions. Read the instructions for the self-checked activity. That means you'll do it yourself and you'll check your own answers. Type in your response to each question and check your answers. At the end of the activity, write a brief evaluation of your work. So the first question says, then it says activity. A submarine is exploring the Pacific Ocean at 502.5 feet below sea level. The water temperature is 63 1/4 degrees Fahrenheit. The submarine dives down 115 feet deeper, and the water temperature drops by 2 1/5 degrees Fahrenheit. What were the elevation and the water temperature after the submarine dove? So we're looking for two different parts here. Assume that the sea level is at 0 feet of elevation. Complete the steps below to solve the problem. So one of the first things we're doing is breaking down the problem into its parts. The first part says, write the submarine's initial elevation as a rational number. That just means a whole number that doesn't continue on like 0.333333, like that. So in this, feet below sea level, I'm copying and pasting because I don't want to mess it up. Control V. All right. Now, the elevation is below sea level. So back on the number line from the previous, it would be below going downward. So I need to put a negative sign there. The elevations below sea level are negative values. The submarine's initial elevation is negative 502.5 feet. Great, we're doing well. Okay, the next part says, which operation must you use to calculate the submarine's change in elevation? Which word or words in the problem signifies this operation? Again, knowing what we're trying to do. So, I would say that the elevation the problem states that the submarine dives down 15 feet deeper. Down, dives down, dives, and down helps me understand that the change is subtraction. Okay? Which words or words in the problem signify this operation? Dives down. The problem states that the submarine dives down 115 feet deeper. The words dives and down convey that the submarine dove farther below its initial level. So I should subtract 115 from negative 502.5 feet. Write an expression to represent the submarine's elevation after its final dive. Then simplify the expression to find its elevation. That's just fancy words for write this problem out. So I'm going to, again, copy words and then make the problem. So minus 502.5 minus 115 feet equals. Then it says, and to find its elevation. So then I need to do that problem. Now on your left-hand side over here, you should see a calculator. I do not do math in my head very well, so I use the calculator. 502.5. Yes, that's right. It is negative, so I need to use this button to make it a negative number. Because remember, it's below sea level. Then I need to subtract the 115 equals negative 617.5. Double check. Yep. Yes. Close my calculator and hit submit. I'm double checking the answer, and it looks like I have it correct. The submarine's elevation after its final dive is 615.5 feet below, or negative 617.5 feet below sea level. See, that's how the words indicate the negative value. Now we're moving on to the temperature. Write the temperature at 502.5 feet below sea level as a rational number. So I don't remember what that temperature was. I got to go all the way back up. At 502.5 feet below sea level, the water temperature was 63 and 1/4. 63 and 1/4. I got to remember that while I scroll down. All right, now how do I type in 63 and 1/4? That will work. Then I could do degrees Fahrenheit, like that, right? But that's a lot of extra work. I need to do it as using the tools that are here. So look at this equation editor. Click on that. And in the first box, you're going to put the 63. Then we're adding the fraction bar to put the 1, and then click down here. Don't click right here. Click down here and 4th, and then click OK. Now, we would love to be able to just copy this and paste it, but it doesn't work that way for us. By the way, we need to remember this 2 1/5 while we're up here. Okay, so 63 and 1/4. We now have it typed in here. Hit submit. 63 and 1/4 degrees Fahrenheit. Awesome. Now, which operation must you use to find the water temperature after the submarine's final dive? So, which word or words in the problem signify this operation? Okay, so in order to find that, we're going to look back up here and see that the water temperature drops by 2 1/5 degrees Fahrenheit. So temperature drops. That's the first part. I know there's a lot of scrolly stuff going on here, which is not easy on your Chromebooks, but bear with me. That we can paste. So the temperature drops. Which word or words in the problem signify this operation? Temperature drops. And then it says, let's see if that's enough. The problem states that the temperature drops. This is a typo. It should be 2 1/5 degrees. The word drop signifies that I should subtract. Sorry, I forgot that. Which operation? Subtraction. So I forgot subtraction. It's important to know what operation you need to do. So how do we subtract 63 1/4, or sorry, how do we subtract 2 1/5 from 63 1/4? Oof, write an expression to represent the water temperature after the submarine's final dive. Then simplify the expression to find the temperature. So I have to do just that. So I need to put in 63 1/4. Okay. Minus, I know it's a little hard to see. And then it was 2 1/5. If these numbers are hard for you to remember and you have to scroll back and forth, get some scratch paper and just jot it down real quick. So I know this might be difficult to see, but it does say 63 1/4, or also known as 1/4, minus 2 1/5, 1/5. So I might not be able to do that in my head. So how am I going to do that? Well, first, I can do the easy part. 63 is a whole number, minus 2 is going to be 61. That part's easy. Now, I don't necessarily remember how to do the 1 1/4 minus 1/5. So I'm going to use my tools. I go to calculatorsoup.com and I type in 1/4 minus or subtract 1/5 and then hit calculate. It does the quick math. The web page is going to load because I've done this earlier. And it shows you that 1/4 minus 1/5 equals 1/20. Wait a minute, how did we get that? Well, there's this thing called the least common denominator. And the lowest number that both a 4 and a 5 goes into evenly, that works for both of those, is 20. For example, 5 doesn't go into 12, 4 doesn't go into 25, but 4 and 5 both go into 20. The least common denominator. There's this whole cross multiplying thing going on. Then, when you do that, you get 5/20 minus 4/20 equals 1/20. So we go back to here and put in our equation symbol, our fraction there, and click OK. Now we have 61 1/20. Submit. Does that check out? 63 1/4 minus 2 1/5 equals 61 1/20. Not too hard, but you got to know how to do it. You got to be able to use your tools. Don't be afraid to use a calculator to work this stuff out. Now you'll complete the temperature part of the problem again, but this time using decimal numbers. Okay, so start by converting the temperatures in the problem statement from fractions to decimals. Now, if you don't know how to do that, it looks like this, 63, and then we're doing the division, so 63 and 1/4. I'm going to do it the quick way here. 63 and 1/4 equals, well, it's still going to be 63 point, we're going to add the decimal, and 1 divided by 4, that's the fraction. 1 divided by 4 equals 0.25. Next, we have the 2 and 1/5, so it's going to be the same thing. 2, same thing, by that I mean the same process. So we're going to keep the 2 and add the decimal, and then 1 divided by 5 equals 0.2. Then it says, that's all it says, okay, but this time using the decimals. So now 63, does it find the water temperature? Okay, so now we've converted the temperatures into decimals. Next, part H says, find the water temperature after the submarine's final dive in decimal form. So I'm looking up 63.25 minus 2.2 equals, I'm going to do that on here, 63.5, sorry, clear, 63.25 minus 2.2 equals 6105. 61.05. So there we go. We've shown our work. This minus this equals that. Is the result, submit. Yes, it's correct. Yay! Did I forget to hit submit on that one? We got 2.2, 2.2, 3.25. Yep, we're still good. Okay, so now it says, is the result that you obtained in part F, A, B, C, D, E, F, 61 and 1/20th, 61 and 1/20th, is the part F with fractions the same as the result you obtained in part H? So does it equal this result in part H, 61.05? 61.05. Are those equal? So the way we can figure that out is 61 small. Now we got to turn this 1/20th into a decimal. We do that, double check by 1 divided by 20 equals 0.05. So is the result I obtained in part F with the fractions the same as the result you obtained in part H? Yes. Explain. Here is our explanation. Yes, the results are the same in parts F and H. You could write that out. That'd be great. Self-evaluation, how did you do? Well, I think I did okay. Scale of 1 to 5, I think I did a 4. There's always room for improvement. I probably could have done my math better. I probably could have added degrees Fahrenheit, learned how to do that, or copy and pasted it. I didn't do that, so I could probably have done better. Then write a brief evaluation of your work. I could write that all out. Note what you learned and what challenged you. I'm going to say 4 out of 5. I could have used better labels. Degrees Fahrenheit, however you spell that, right? And I learned how to use the equation, what was that called? Equation editor, and calculatorsoup.com. All right, hit submit and move on. Now, if I hit save and exit, I don't know that this actually saves, but I'm going to do it just because if I move forward and something happens with my computer, I don't want that progress not to be saved. All right, so now I'm going to move on. I hesitate to go back a button because I think it's not going to be there. Maybe it stays. I don't know. Let's move on. Okay. And if you needed to, you could have printed that assignment. Okay, here we go. Moving on.
When solving a problem, you can figure out which operation to use by looking for keywords in the problem. The table lists some keywords that suggest addition, subtraction, multiplication, and division. If words such as more, sum, and deposit appear in a problem, use addition to solve it. If words such as divided, separated, and broken up are used, look to division. Likewise, look for the keywords related to multiplication and subtraction. Some words such as combined, together, and total indicate addition as well as multiplication. Addition and multiplication have common keywords because multiplication is the same as repeated addition. Let's look for the keywords in a problem. Lana works 8.5 hours a day. At this rate, what is the total number of hours she'll work in 5 days? Notice that the word total appears in the problem. This keyword tells us that the problem can be solved by either multiplying 8.5 by 5 or by adding 8.5 hours 5 times. Some keywords also apply to the signs of values. The terms rise, more, and deposit denote positive values. The terms fall, less, and withdrawal suggest negative values. Next, you'll solve a word problem using keywords found in the problem statement.
All right. Select the correct answer from the drop-down menu. Gretchen withdrew, so we know that she is subtracting a value. So she subtracted $31.45 from the bank to buy groceries. Then she deposited a check. So deposited is a positive, it's addition. Which expression represents the net change in her bank account? So the total, net is total, change in her bank account balance as a result of these two transactions. So which expression? So that means we want to see the expression, not the answer, but the actual problem. So our options are minus $31.45 plus $27.89, minus $31.45 minus another 27.89, positive 30, even though there's not a positive sign here, it's 31.45 plus 27.89. So if we do our lines here, I'm sorry, I'm going to delete that and go back to this greenish color. So this is subtraction, and this one is addition. That alone helps us identify that this one can't be it because it's not subtraction. This one can't be it because this is not subtraction here. So by process of elimination, that's the problem. Then we do the math to find the net change. So back to our calculator again. So 31, it's not letting me use the keyboard on my mouse pad here. 31.45, and remember that's minus plus 27.89 equals minus 3.56. Let's see if that's one of our options. Minus 3.56 is one of our options. These other two are way different. All right, correct. Gretchen withdrew $31.45 from her account. The word withdrew signifies subtraction or a negative sign. So the net change in her account after this transaction is negative 31.45. Then she deposited 27.89. The word deposited signifies addition or a positive sign. So the expression representing the net change in her account balance after these two transactions is negative 31.45 plus 27.89. The net change in her account balance because of these two transactions is negative 31.45 plus 27.89 equals negative $3.56.
More real-world problems. Here's another problem for you to try. Callie was billed $416.48 for car repairs. She will pay the service center in 4 equal monthly installments from her bank account. What is the net change in her bank account balance after each monthly payment? In the next activity, you'll help Callie better understand her monthly payment plan.
All right, so this activity will help you meet these educational goals, mathematical practices. You will make sense of problems and solve them and reason abstractly and quantitatively. That is wordy for use it in the real world. If you believe that you will not use algebra in the real world, you are mistaken. We do it all the time. How many payments how much is each payment going to be? So Callie was billed $416.48 for car repairs. She will pay the service center in 4 equal monthly installments from her bank account. What is the net change in her bank account balance after each monthly payment? So how much does it change after each payment? Complete the steps below to solve this problem and others like it. In terms of the entire bill, which rational number represents the net change to Callie's bank account? So what's going to be the total change after the 4 equal payments? What does the sign on the number mean? All right, so $416.48. And then it's going to be, because it says, so that's the rational number that represents the net change, that's how much is going to total come out. And then we want to show that it's in 4 different payments. So we're going to go like this. And this is actually the 416, actually, sorry, it's minus 416.48. I made a mistake here. So $416.48 over 4 payments. And it is minus. All right. So I know that looks really weird, but she's going to pay a total of $416.48 literally over the course of 4 payments. What does the sign on the number mean? It means it's negative. It means she will lose that much. She will pay out that much. It'll decrease. The net change to Callie's bank account is negative $416.48. The negative sign indicates money leaving her account. Which rational number represents the number of months that Callie has to pay? And what does the sign on this number mean? Okay, so again, it's the same concept. The number of months is 4. What sign is there? None. It's positive. So that means number of months, and you can't go back in time. So number of months. Yes, let's see. Callie has 4 months to pay off the bill. The rational number is plus 4. The sign is positive because it represents a quantity of something. In this case, months. Yeah, like I said. Write an expression to represent the net change to Callie's account balance each month. So again, that probably did that one way too soon, right? The amount of the bill, negative $416.48, will be deducted from her account in equal amounts over 4 months. So the expression representing the net change in her account balance each month is negative 416.48 over 4. Now it says simplify the expression in part C, that's this, to find the net change. So this is how much is going to come out each month. What is that number? So how do we solve that? We go back to our handy dandy calculator. We type in 416.48. Remember the minus sign. Gotta check your sign. I saw the sign. Opened up my eyes. I saw the sign. Okay, continuing on. Divided by 4. And that'll give us how much each payment is. So it'll be negative equals negative $104.12. Now, yep, that checks out. After paying the car's service center in full, Callie realizes that she should start saving money each month for her future. She decides to invest the same monthly amount that she was paying the service center. This is how much she was paying the service center. in a retirement fund. If she invests in the retirement fund for 1 year, what will the net change in her account balance be during that time? So let's use the same steps. Okay, so if she invests in a retirement fund for 1 year, what will the net change in her account balance be during this time? So 100, $104.12, and it's positive because she's saving it. And I'm going to use the equation editor and make it a fraction over, and help me out here. How many months in a year? Oh, 12 months, right? Okay, but that's division. That's not right. Let's see. 112 over, I think that because she's not paying out and dividing it, she's actually adding it up. Remember that multiplication or repeated addition? So we could do 104.12 plus 104.12 plus 104. Oh man, 0.12. Yeah, see, I'm already tired of that. I can't do that. Okay, so instead of continuing on doing that a bunch of times, we're going to do 104, excuse me, 104.12 multiplied. Now, X is a multiplication symbol, and also is this asterisk sign. So either one of those is okay. Also, another way you could do it is parentheses, and then outside of the parentheses put the 12. That also means multiplication. Same thing. They mean the same thing. So over here we can do the math. 104.12 times 12, and it says, what will the net change in her account balance be during that time? So it's that much per month. So actually this would be over 1 if it was per month. Okay. Equals 1,249.44. That 0.44 makes sense because 12 times 12 is 144. All right, let's hit submit. All right, yep, it looks like our math paid off. All right. This says her net account continues to be negative $104. Why is it negative? Because it's coming out of her bank account and into her retirement fund. So I did not watch the sign. I did not watch the sign. Lesson learned. What is the sign of the net change? Negative. Subtraction. What does the sign, why does the sign make sense in this situation? Because she is taking it from her bank account and adding it to her retirement. Okay. The net change is negative $1,249.44. The sign is negative because it represents money leaving or being deducted from her bank account. Self-evaluation. Ooh, scale of 1 to 5. I'd say a 4 out of 5. I missed the sign. All right. Submit. Next.
In the activity, you calculated the net change in Callie's bank account balance after deducting the payments to the car service center. You also calculated the net change in her account balance after she withdrew money each month for her retirement fund. You used both division and multiplication to solve the different parts of this problem. Next, you'll solve a problem involving all 4 math operations.
All right. This says drag each tile to the correct box. Order the expressions from least value to greatest value. So essentially, we have to use that scratch paper that I said and figure out what the values of these are and determine which one is the least and which one is the greatest. Remember, the little alligator chomps the greatest number, and that's the way they have it set up. So one of the ways we can do that is by using the calculator and figuring out the value of each of these and making a note of it. So 2.2, which is a negative 2.2, multiplied by 3.4 equals negative 7.48. Negative 7.48. It's not easy for me to write like that. I also have sloppy handwriting, so that's that. 4.2 divided by negative 6. 4.2 divided by 6 negative equals 0.7. Negative 0.7. So this one is negative 0.7. All right, so of those two, which one's least? Well, this one has something in the whole number range, and this one has 0 in the whole number range. Okay. And so I believe that makes this the least out of these two. All right, next one is negative 3 3/5. So, let's look at our calculator there. Negative 3 minus negative 3. So, oops, 3 minus, okay, minus 3 negative equals 0. So it's going to be, the 3's are going to 0 out. So then we have 3/5 minus, negative 3/5 minus negative 1/10. Let's go back up here. Remember this guy? Negative 3/5 minus 1/10. All right. And that equals a half. So negative minus a negative. What was that? Another way, so it's 0.5 or half. Now I have to double check the signs. I hope that makes sense. So it equals a half, but I need to know the sign. Negative minus a negative is the same as a negative plus positive. So I think that's a positive half. When in doubt, use another tool. So what I'm going to do is I'm going to use my handy dandy Photomath app. And it's negative half. Negative half. Because it's the same as a negative plus a positive. Okay, so it's negative half. Okay, negative 2/3 plus negative 3/16. I mean, negative 3/4. I'm sorry. So this one, I want to convert these into decimals because I think it'll be easier to do the decimal numbers than the fractions. So 3 divided by 4 equals 0.75. So this is negative 2.75 plus negative, and then let's do 1 divided by 6 equals, so that's 3.16666. So it's going to be about 3, oops, 3.17. It's going to be about, but it's minus, okay? So 2.75, whoops, typo, 2.75 with a minus sign plus 3.17 with a minus sign equals, I hit equals twice. Dang it, gotta start over. 2.75 negative plus 3.75. Nope. Dang it. Keep messing up. Gotta watch it. 2.75 negative sign plus 3.17 with a negative sign equals negative 5.92. Negative 5.92. And if you knew that, if you did that already, then awesome on you. And I will say it over and over again, math is not my strong suit. Okay, so now we have to put those in order of the least to greatest value. Okay. So is that going to mean most positive? If that is the case, what is closest to positive? But negative has a value too. So I'm going to say this one goes over here with the negative 7.48. This one with the negative 5.9, 2.5. So 0.7 is more negative. So that means it's got a greater value than negative 0.5 or negative half. Let's see. Oh, incorrect. Try again. Oh, no. Okay. So I must have it backwards. All right. So try again. All right. So if I had it backwards, and I apologize for confusing you, that means that this is the most negative. That means that, let's see, this is the most positive. It's the closest to 0, closest to 1. So the greatest in value means most positive or closest to 1, closest to the highest value. That means this one comes next. And finally, this one in between. So negative 7.48, negative 5.9, negative 0.7, and negative 0.5. Try it again. Yes, correct. This is the explanation. See this symbol right here? That means about. So it's about at 5.91. About 5.91. That's what I was saying, because it normally was 1.66 and it trailed off. Now we don't have that anymore. There we go. Next problem. Let me erase all this too.
You can use addition, subtraction, multiplication, and division to solve real-world problems involving rational numbers. Be sure to read and analyze each problem carefully. You can use several strategies to solve real-world problems, such as drawing a picture, working backward, guessing and checking, making a list, and using logic. Certain keywords in a problem can help identify which math operation to use when solving. For example, the words sum, total, and deposit signify addition. Words such as less, fewer, and drop signify subtraction. Addition and multiplication have common keywords because multiplication is the same as repeated addition. Words such as total, together, and combined signify that you can use either addition or multiplication to solve the problem.
All right, congratulations. You completed the tutorial for add, subtract, multiply, and divide rational numbers to solve real-world problems. Remember, if at first you don't succeed, maybe skydiving isn't for you, and what you think on grows. I hope you enjoyed this video. If you have to watch it over again to complete this tutorial on your own, I completely understand. Have a nice day.